Good afternoon, good morning. I think we have a very interesting topic for today. We're looking at Belgium's hydrogen strategy. And for those of you all who are here for the first time, my name is Nishaanth Balashanmugam. I'm the CEO and director for GH2 India. And this is part of our monthly webinar series, but also this is a second activity since we signed an MOU between the Belgian Hydrogen Council and GH2 India to promote trade partnerships between both regions on green hydrogen. So today we are looking at the hydrogen policies in Belgium, and we have, I think, a very excellent presenter, Stefan, who is joining us as a representative of the port of Antwerp-Bruges, and he's been in the sector within several key stakeholder groups over his career. So I think he'll have not just policy insights to share, but also his own personal experiences. So before we move on further, I want to invite Dr. Prasad Chaphekar, who's the Deputy Secretary at MNRE, for a special address.
Thank you. So thank you, first of all, for having me here. I had the opportunity to visit the port of Antwerp-Bruges, the beautiful office of which you have the screenshot behind you. I was there in November of 2024 in the Hydrogen Week. So I had a chance of interaction with the port officials along with my secretary, MNRE, at that time. I'll just give an update on what India is doing as of now and a few pointers ahead for the way forward. As you know, we have just concluded the largest tender for green ammonia in the world for 10 years supply at record low prices. Those prices are at the point of delivery. Of course, I get questions that whether the RFNBO compliant. So the answer is they have to comply to Indian standard of green hydrogen or green ammonia. It is not required for them because we as a country cannot legally enforce other countries' standards for our incentives. So we have obviously we will hold them accountable to our standard, not other country standard. But even to meet India standard, they have to use at least 95% energy which is renewable. So invariably, most of them will end up meeting RFNBOs. That's the first. The price we discovered was around $600 roughly per ton of green ammonia. So that's pretty competitive. That's the landed factory price. Of course, if you export to Europe, it would be a bit more. You have to add around $100, I guess, for shipping. But even considering that, it is at least $300 less than the Hindco tenders which were discovered about a year back. So our producers have shown their capability to produce green ammonia at a very large scale at competitive prices on commercial terms. I'm aware of the size of the European market, and as you know, we have been coming to Rotterdam for the Hydrogen Summit every year almost for the past 2 years now. They've also been to Hydrogen Week last year. So we are pretty strong in our outreach. We know where our customers are, and we would continue this outreach in the coming years because we know the value of Europe as a customer, as well as the leader in use of these fuels. Regarding our future plans, we still have a few funds which are unallocated under our subsidy. So whenever our industry finds that there is a case for long-term offtake, for example, the IMO mandates are going to come probably in the month of October, which would give at least a 3 years time for us to know what is the quantum required, after 3 years down the line. And since the plant construction itself requires around 3 years time, so that would give us sufficient time to have, if Europe has a confirmed offtake, we can put a joint tender where we give our subsidy to our producers for supplying in European ports, especially ports who want to do bunkering in Europe and supply green fuels in Europe. So Port of Antwerp could definitely consider this opportunity to team up with our government so that even the cost to your taxpayer and your cost will also be reduced as compared to other sources of acquisition of these fuels. I will not give a full review of the mission. We can have a separate meeting for that. I just mentioned that we are doing a whole lot of pilot projects in steel, in shipping and transport. We're spending a lot of funds on R&D as well. So we are doing this mission in all probable areas where you could use hydrogen. If you're interested in the details, please come to us. We can have a separate session where I'll give you the entire details of our mission and where we stand now. So with that, I conclude my remarks and I hand the floor to you. Thank you.
Thank you very much, Dr. Prasad. I think we are having a more dedicated session to showcase the National Green Hydrogen Mission for Belgian stakeholders in the coming weeks. So I think before Stefan can present on the hydrogen policies, we also have Bert, who's the CEO of WaterstofNet since August 2023. Bert, you've been playing a very key role in building all of these partnerships, and thank you so much for your support to Indian stakeholders and for recognizing India as a key partner. So over to you for some welcome remarks and setting the context. Thank you.
Thank you very much for organizing, and a pleasure to see you again from distance. But we appreciate the linking up between Belgium and India, and we have set up this short introduction webinar on what we have signed and how we look forward to the activities between our both countries. I'm the CEO of WaterstofNet, and we are the program office of the Belgian Hydrogen Council, together with our colleagues from the southern part of Belgium, cluster Tweed. The Belgian Hydrogen Council has basically four different ambitions. First, when we are established about 2 years ago, we were asked to be the Belgian voice, the Belgian industry, towards the government. I think we're trying to gather the Belgian industry and have a direct relation with our Belgium and regional governments to explain the ins and outs of hydrogen, the benefits, and what is at stake and what could or should be done. In that way, we're profiling and promote the Belgian industry. And when we go on international missions, we call ourselves Team Belgium, not only in the athletics as going on in Japan at the moment, but also in the hydrogen field. We advise the policymakers explaining why and how they could help us by adequate policy. And probably most important is linking up the full hydrogen value chain, the different regions, but also wider with our neighboring countries and further out with the different partners across the world who have the opportunity to produce the hydrogen, as we are here in Belgium, Benelux, together with Germany, in the sweet spot of hydrogen. We don't have enough green energy. We will need to import green energy. And that's one of the reasons why we believe it's important to link up our both countries. I will quickly explain our ambition as the Belgian Hydrogen Council, what's going on in Belgium, and sketch also the basis or the basics from the MOU which we have signed. Next slide, Stefan. Thank you for sharing. As part of the different discussions next to the MOU we have signed in India during the missions, we have signed with Oman, we have signed with our neighboring countries, Germany, Netherlands, and France, because we believe that it's important to gather the Belgium industry and have a common voice, a one voice approach towards all of these partners, these different countries. Next slide. The ambition of Belgium in the wider context is because of our geographical location in the center of Europe, if we may say, and also because we are right in the middle of the sweet spot of hydrogen in the Benelux, Germany, and France, where we have not enough green energy, so we need to import. We believe that with our capacity, with all the different harbors, we could feature as the import hub of green energy / hydrogen in these regions. We have the port of Antwerp-Bruges, we have the North Sea ports with Ghent and Vlissingen, we have closely linked to the port of Dunkirk and Ostend. A lot of capacity to bring in hydrogen in its different ways and forms from across the world into this region, together with the currently being built pipeline network. You can see on this slide and the different green lines for internal distribution in Belgium, but also to our neighboring countries, the Netherlands, primarily Germany, also Luxembourg and France. So our ambition is that by 2030 we would hydrogen in a volume of 45 terawatt hours per year, of which about 1/3, so 15, is for internal consumption. I'll come to that in a minute. And then 2/3, 30 terawatt hours, is for throughput to our different neighboring countries. So point I want to make is that we need a lot of hydrogen by 2030, but if you see the green bars, we believe by 2050 the volume will importantly increase. So we will elaborate to assure all the necessary capabilities to be able to import all those volumes of hydrogen, and being able, with the pipeline systems we currently being built, to have the throughput to our neighboring countries. A small amount, of course, in order to illustrate and to modulate some of the different energy, will be also internal produced. So we will have a small fraction of internal, but we will largely depend on the import and the volume imported from throughout the world. The next slide indicates on how we're going to use. So apart from the export to the different countries and some local production, which you can see on this slide, we believe that here in Belgium we do have quite a lot of interest to have local consumption, so off-taking, in the different areas which are indicated. Of course, the heavy-duty transport, which goes to heavy transport by trucks, aviation fuel, synthetic aviation fuel, even maritime applications in sea or river transport. The steel production, which we have here in Belgium, could feature or could use a lot the hydrogen imported. Antwerp is the second biggest chemical cluster in the world after Houston, and they need a lot of energy, and they need a lot of hydrogen as a commodity, as a chemical building block. So also there will be a great opportunities for offtake, and any new or complementary application like glass, cement, or fertilizers. The first point of strategy is the import. The second point of the strategy is the internal consumption, which I illustrate on this slide. And the third one is the capacity, on the next slide, is the capacity we have as technology providers. At the moment, we have two important electrolyzer manufacturers with Cummins and John Cockerill. And we have different component suppliers like Agfa with the membranes, Bekaert with the diffusion layers, Borit with the bipolar plates. So all important components which are necessary for the hydrogen production. And I'm sure in India you have heard of all these. With all these components and many more, I will limit the discussions, many information you can find on our website. We are able to produce the applications ourselves, which you see on the bottom part. It's a mobile applications, stationary applications, production applications, the pipelining. So we have a lot of possible applications. So I think there are many reasons why we want to talk to the hydrogen production side. And for that, next slide, we have signed recently the MOU between our both countries. As said and explained in this one, the drivers for the MOU is, first of all, your abundant in India, abundant renewable energy sources for or could be used for making hydrogen. And our ambition, of course, for the internal consumption, but also to be the gateway or the import hub for hydrogen in Europe. Now, what is written in that MOU, simply said, these are hooks we can hang on any further ambition, any further collaboration. So it's about the technology collaborations, is to exchange some knowledge and best practice, part of what we are doing today. The trade facilitations to make sure we develop supply chains, new supply chains for the production, the transport, and the import, what we do here. Stakeholder engagement, we have to make sure that all our industries, our governments, understand each other. Financing, some joint forums and collaborations to motivate, to stimulate policy discussions and showcase what we are actually doing, and making sure that we understand each other ecosystem. In both regions, we know what we do from each other, so we can rely on each other's capacity. That's what's been signed in the MOU. And part of that implementation of that MOU is today's discussion, as you can see on the next slide. We have elaborated, if I'm correct, yes, we have elaborated a couple of activities which are going to happen in the near future. During the EU Hydrogen Week, there is a delegation coming over and having a visit in Antwerp. We have a webinar planned on the 13th of October. Following that, we plan, and still we need to work on that, the roadshow in India, which is happening in the Indian Hydrogen Week. And then we have the Hydrogen Summit and the HYPEX seminar. So this is just one part in the sequel of activities we're planning to do. So this just as a very short introduction. More information you can find on the Belgian Hydrogen Council website, but by all means we are available to answer any of your questions. Contact persons in the different organizations from WaterstofNet, Isabel and Michel. And then for Fluidens Investment and Trade, and then the Port of Antwerp and Bruges. So you have several contact points, so feel free to go forward.
And for those of y'all who are wondering what those terawatt hours of hydrogen import translates to in tons, I think Belgium is looking to import about 1.3 million tons by 2030 and close to 8.3 million tons by 2050. So I think India will be a key partner for Belgium to achieve these import targets of hydrogen. But also, I think it's time for us to build context on the larger India and Belgium partnerships, And there's been several collaborations in the agricultural sector, in the pharmaceutical equipment sector, in the defense, and also in diamonds. I think diamonds has been one of the biggest, exchange of trade between the two countries. But now green hydrogen provides a lot of opportunities. And in fact, today, there's ACFA in India with about 40 people based out of India, and they make the front membranes for electrolyzers. We have Relay as well. They've been working on Green AM Green's Kakinada project. And then, of course, John Cockrell, and the partnership between John Cockrell and AM Green is one of the most significant partnerships in the sector between Belgium and India. And I think today we all need to work together to ensure that all of these ambitions translate into real projects and business. So with that, let me welcome Stefan from the Port of Antwerp. Stefan, over to you.
Yes, thank you, Nishaanth. So my name is Stefan van Laer. I work for Port of Antwerp-Bruges. Don't forget the Bruges, a mistake that we also sometimes still make today. So I work in the Sustainable Transition Department of Port of Antwerp-Bruges, and more specifically in the Hydrogen and CCUS team. And together with a couple of colleagues that you see here on the slide, we work specifically also on this MOU that we, or the Belgian Hydrogen Council, has signed with GH2. So you have our contact details here on the slide. Some of you might have already met Daljit, who is our port representative based in India. So maybe, Nishaanth, I heard you mention in the beginning a couple of times that today we would discuss Belgian policies. I can definitely make a sidestep here and there towards those policies, but today actually the focus of the webinar is on the Port of Antwerp-Bruges hydrogen import strategy and our connectivity towards the hinterland, mainly Germany. I do think that in one of the following activities, doing such a dedicated webinar or seminar or workshop or whatever you want to call it, either via webinar or via live meetings, for example, during EU Hydrogen Week or doing a World Hydrogen Summit in Rotterdam. I think it's definitely a very good idea to zoom in a bit on what are the policies in Belgium, and we're translating these European legislations into national policy as we speak. So we hope to have more clarity by the end of the year. Then compare RFNBO criteria with your own criteria. So I think that's definitely a good idea for the future. But today I will focus mainly on our strategy and on infrastructure. So maybe as a general introduction to Port of Antwerp-Bruges, for those who might know our port, the name already indicates that it's actually a merger of two ports. So about 3 years ago, a bit less than 3 years ago, we merged the ports of Antwerp and the ports of Bruges. So now we really talk about one port. We have one CEO, one board, so one management, one strategy, but we have two platforms, one in Antwerp and one in Bruges. You see that also here. Maybe the next slide is even better. You see it here geographically. There is actually about 100 kilometers or 80 kilometers of the River Scheldt between the two platforms, where Zeebrugge is really a deep sea port located at the seaside in Zeebrugge. And Antwerp is more of a fluvial port, but due to dredging and years of experience, we are welcoming the largest seagoing vessels also in Antwerp. So in terms of draft and welcoming these large ships, this is not a problem at all. What was actually after merging the two ports, the two platforms, we have become the second largest port in terms of container capacity in Europe after the port of Rotterdam. And in the first quarter of this year, we also have briefly surpassed Rotterdam in terms of container traffic. Also, one of the important aspects or qualities of our port was already indicated by Bert in the introduction, is that we host the second largest petrochemical cluster worldwide in our port in Antwerp. So we have a lot of containers coming in. We have a lot of customers actually in the port itself, in the chemical cluster, which also leads to the logical consequence that there is a huge amount of logistical traffic actually going on in our port. And if you would take the broader picture, so not only our port, but would take Port of Rotterdam in there and Port of Duisport, which is called the ARA region, so the Antwerp, Rotterdam, Amsterdam, Rhine-Ruhr region, we have 40%, so 40 of European industry located in this triangle. and basically the bulk of the heavy-duty logistics is also going on in this triangle. So, long story short, huge energy demands, huge demand for energy, for hydrogen to decarbonize our chemical industry, to decarbonize the logistics going in between, and to decarbonize our economy as a whole. So maybe as a side step, what was actually the reason of merging the two ports or merging the two platforms? First one is that actually the two platforms are more complementary really than they were competing. So in Antwerp, as mentioned before, we have the petrochemical cluster, which you see here on the slide. So on the top right, you have a bit the who is who of our petrochemical cluster, what companies are present here in Antwerp. You see on the bottom the names of the companies. I'm not going to go through all of them, but you see a large German presence as well. So you have BASF, so the entire top part you see there, numbers 1 to 5, is basically all BASF. So it's the largest BASF site outside of Ludwigshafen that is in our port. And the same goes for a couple of other companies who basically have their largest facility right across the border in Germany, so in the North Rhine-Westphalia area. So, for example, Evonik, Bayer, Covestro, Lanxess, all of them have the largest facility in Germany, and then the second largest in our port. So there is historically and infrastructurally a large connectivity already today between our ports and the German hinterland, which is also why we are focusing a bit on that in the second part of this webinar today. So a large petrochemical cluster in Antwerp, making us already an energy port today. So we have 20 million tons of chemicals output every year. We are a large LNG import hub, which I will come to in a minute. We have 2 refineries in our port with ExxonMobil and Total Energies with a 40 million tons of oil refinery capacity. Already today, there are 1,000 kilometers of pipelines running through our port, which transports over 60 products. So goes from all types of chemicals you could imagine. And already quite some tank storage capacity also today. So the storage of ammonia, the storage of methanol already being done today, it's nothing new to us. So also in terms of safety, in terms of permitting, we know how to do it. The only thing that might change with the energy transition is, of course, the size of things and the scale of things that might and probably will increase. So large petrochemical cluster in Antwerp. And actually here what you see on the slide is a picture of our Zeebrugge platform. And on the right you see, you only see 3 of them, but there is actually 4 LNG import terminals. And so 15%, you see on the slide, of the EU gas LNG is actually being imported today through this terminal. Of course, since the Russia-Ukraine war, this terminal became even increasingly important, and large quantities of the gap that was created by the sabotage of Nord Stream 1 pipeline towards Germany was filled in through this terminal. So that's fossil, of course, today, a service that we deliver to Germany today. But of course, in the future, we would love to do the same for low carbon molecules, ammonia, hydrogen, LOHCs, whatever carrier you can imagine. And this might be an ideal location in the future to build such an ammonia terminal, for example. So that was the introductory part. Let me change. Okay. Maybe one thing that I haven't mentioned yet. So it was a bit of a good news show up until now. So the second largest port, large logistical hub, second largest petrochemical hub. This, of course, comes with a price, and the price is CO2. So 18 million tons of CO2 is emitted in our Antwerp region alone, so which is more or less 20% of the total Belgian emissions comes from our port platform here in Antwerp alone. So as any other decent company we developed a climate transition strategy based on multiple pillars you see here on the slides. So working at efficiency, also working at fuel transition to provide bunkering providers in the future, also with sustainable fuels, working at carbon capture and storage you see on the right, but hydrogen is really our feedstock pillar that we are working on. So today in our cluster, already 500,000 tons of hydrogen is being consumed today. So that's gray hydrogen as we speak, and that needs to be decarbonized, of course, in light of climate transition. And I will focus on this third pillar, the hydrogen pillar, for this webinar. So here on this slide, you see the total picture of our roadmap for hydrogen towards 2030. It's a bit much, but don't be overwhelmed. I will break it up in the next couple of slides into different pieces, walking you through it piece by piece. Maybe as a general remark here is that you see that we work on three pillars. The supply, where will we get the molecules? Will we produce them ourselves? Will we import them? Will it be blue? Will it be green? What type of molecule will it be? That's in the supply part. And infrastructure, extremely important, of course, is divided into two pieces. One is the pipelines, and the other one is the import terminals and cracking facilities. And then towards the end, of course, somebody has to consume the hydrogen once imported. So we work also very much on the offtake, which might be the most difficult piece of the puzzle today. But we're working very much with the companies to make this reality. And then on the right, you see the timeline from today, 2024 or 2025 towards 2030. What steps do we need to take to be ready by 2030 to actually start importing at large scale? General remark, we are color agnostic, meaning that we will accommodate any type of molecule that will help us reach the climate goals, except for gray, of course, although the legislative framework in Europe is of course pushing very much towards RFNBO or green hydrogen. Also, in terms of carriers, we are not discriminating, so we're really looking at e-methane, ammonia, methanol, LOHCs. We will make sure that our port is ready to accommodate any type of these carriers. We just monitor the market and we make sure we make our infrastructure ready. So that's as a general word to this slide. Then we start with the first part, which is supply. I think Bert already indicated briefly in the beginning that Belgium is a country, and actually the region around us is defined by the fact that our energy consumption or the need for energy is far larger than our own potential to produce renewable energy. And for Belgium, it's even more the case than, for example, for the Netherlands and Germany. If you would have a look at the Belgium geography, if you would open your Google Maps for a moment, you see that we have a coastline, but it's quite short. It's 70 kilometers, more or less. So we're working very much on offshore wind. We're working on wind parks in that region. But basically, the electrons coming from those wind parks will have to be used for direct electrification of our transport, of our chemical cluster, of our industry. So basically, we don't have a surplus of electrons in Belgium available for large-scale hydrogen production. That doesn't mean that we don't do anything. We have a 25 megawatt project in Zeebrugge already being built today. It's small, but it's one of the pioneers, so it's being built, which we are proud of. But of course, when we talk about the large quantities, they won't come from this project alone. We're working also on a blue hydrogen project that is bigger of size, local production, but that's more or less about it. So long story short, we're looking very much at importing hydrogen, which Bert already indicated. And together with a couple of Belgian players like DEME, who's a project developer, like Exmar, who's a shipping company, ourselves, Fluxys, who is an infrastructure company building pipelines, we have developed the Hydrogen Import Coalition. So if you would Google report Hydrogen Import Coalition, you would find a detailed report that actually calculates back from European targets towards Belgian context. So what do we need? What are the volumes we are expecting? What are the terminals we would need? What are the K-walls we need? What types of ship we would need to actually make these ambitions, European ambitions, reality in Belgium? And so this was already indicated by Bert. This more or less leads up to numbers of importing 1/3 for local consumption in Belgium and 2/3 for the rest of Europe, mainly Germany. So this is not an invention of ourselves. So we have compared this also to the German hydrogen strategy. And so the numbers align quite well. It's what we do also today for natural gas. We import 1/3 for our own consumption and 2/3 go to the rest of Europe, mainly Germany. Now, this was developed 2021, if I'm not mistaken, maybe 2020 even. So things have changed, of course. Russia-Ukraine war, new geopolitical context, new economical context in Europe. So we have done the same exercise more or less again last year, together with the terminals who are developing projects here in Antwerp, and so we have tried to come up with maybe a more realistic or adjusted number, but still today you see that we could import by 2030 between 1 and 2 million tons of hydrogen equivalents by 2030. 1/3 for Belgian demand, 2/3 for throughput towards Germany. So even though the storyline you hear in the press is a bit less enthusiastic or hyped as a few years ago, we still see realistically quite some demand developing here in Belgium, in the region, maybe a bit slower than initially thought, but still the demand is there slowly but steadily. And in a potential future workshop, we can definitely go into it more detailed. Where is this demand? How is it based on policy? What type of policy? So I think that might be interesting for one of the following activities in this MOU. So we will have to import. Where will we import from? You see a couple of countries highlighted here. This is non-exclusive, but basically it is what today we feel are our most privileged partners or most advanced partners, to say so. India is definitely one of those regions. Distance is, of course, crucial in this exercise. So you also see Australia highlighted, which is probably quite unlikely that these molecules will ever travel all the way across the globe to us. We hope that they will, of course, but more likely that they will go to the Asian market. But India is becoming a large, ever increasingly important partner for us, of course. One side step in this regard is to our daughter company, so our subsidiary called Port of Antwerp-Bruges International. You see the logo on the bottom right. So it's not just the international service of Port of Antwerp-Bruges, it's really a separate company with a lot of interlinkage, of course. What they do is they are historically a port consultancy company, so they have projects worldwide already for quite some years. For example, in the port of Cotonou, they provide consultancy to this port authority to help them in building out a port, how do you manage a port, etc., etc. But now with the energy transition, also looking more and more into hydrogen projects. And so in that regard, we are also, through this vehicle, investing worldwide in other ports with the aim of exporting ammonia and hydrogen towards our ports or across the globe. So, for example, we have bought a stake in the Porto do Açu in Brazil. We have a stake in Port of Duqm in Oman. And the latest news was also that we will invest together with Namport in Namibia in Walvis Bay to build out a complete new port there with the aim of exporting molecules across the globe. So when I showed you in the beginning the team of Port of Antwerp-Bruges that is working on this MOU together with GH2, Achille was on that slide, and Achille is working at Port of Antwerp-Bruges International. So I call him a colleague. He is a colleague, but so just so you have that slight nuance with you. Coming to the infrastructure part of our import strategy, I mentioned before it's two parts. One is the pipelines, and the other one is building import terminals and cracking facilities for ammonia or LOHCs. In this slide, you will see the publicly known projects that are being developed for now. So first one is Fluxys and Advario collaboration. So Fluxys is a name that you will hear a bit more further down. Is actually our national gas grid operator historically, but also since 1 year or 1 year and a half has been designated by Belgian law as a hydrogen network operator. But they're also developing an import terminal for ammonia and a cracking facility in our port together with Advario, with the aim of becoming operational by the end of 2029, 2030. Of course, timelines are always difficult. A second project, interesting one, is Vopak. What they have done is that they have acquired a plot of land in our port, which actually was a refinery. It was a Gunvor refinery that had to close shop during the COVID crisis and never opened again. So we got the concession back as a port, and again we put it into the market for clean energy developments, and Vopak won it. So it was quite impressive to see that they have, during the past year and a half, they cleared out the entire plot. So the refinery is gone. All the old terminals, storage tanks for diesel and for crude oil and you name it, have been torn down. And what they are doing now is a complete soil remediation, which should be done, let's say, by the end of the year, maybe a bit further into the new year. And then they will have a 90-acre, if I'm not mistaken, plot completely available for new energies, CO2 storage, ammonia cracking, methanol storage. So very interesting case. They recently announced that they have finished pre-FEED and entered into a FEED study for this project. Then VTTI, a similar project, open access ammonia terminal and cracker, also here in Antwerp with the timeline 2030. Also, they have announced recently that they have filed for their environmental permits. So just to show you that these projects is, and as past PowerPoint presentation, they're really taking steps. And we hope to see one of these projects taking FID in, let's say, beginning 2026 or 2026. We hope that will be a milestone. Then last but not least, we hear a lot about ammonia cracking worldwide, but it's mostly hopes and dreams and plans most of the time. We actually have with Air Liquide a first industrial scale pilot operational as we speak today in Antwerp. So it's located at the BASF site. Air Liquide has revamped part of an SMR into an ammonia cracker. It's operational today. They're testing the technology with this, and they have also received European funding to build actually a fully large-scale industrial cracker in our area by 2028. So these are the four, let's say, publicly known projects. There's projects apart from that being developed by C-Tank, by LBC. So they prefer not to be on a slide. So we respect that, of course, but just know that if you want to contact all the terminals, there's more than these four alone. Then maybe interesting second daughter company we have at Port of Antwerp-Bruges is Pipelink. It's an infrastructure company, and as the name indicates, specialized in point-to-point pipes. So these 1,000 kilometers of pipes that I mentioned in the beginning is operated by Pipelink. They're also developing an ammonia backbone in our port locally, only in our port, because ammonia is being produced, is being imported, is being used in our port. So it makes sense to have an ammonia backbone as well. And then the second part is, of course, the infrastructure. Bert already showed this and said most of it. We're building out a newly built hydrogen backbone in Antwerp, in Belgium. First phase is already being built as we speak, which is connecting all the industrial off-takers in our port in Antwerp and connecting our port to the port in Ghent, where you have ArcelorMittal, which could be potentially also a large off-taker in the future. So that's phase one. And then phase two is building out the rest of the network, with, for us, of course, the connection towards Germany, a very high priority. And Fluxys is aiming to make that connection by the end of this decade. to then connect to OGE, which is the operator from German side. And it's interesting to know for you that Fluxys has a 25% stake in OGE, which of course makes all discussions on the what and the how and the where we will make this connection a bit easier, of course. Okay, then coming to offtake. I think I already mentioned most of it. So on the left, you see the picture again of our petrochemical cluster, which I mentioned. Consumes 500,000 tons of hydrogen already today. This is the current use. There might be some new uses popping up in the future, like for example, Ineos is building its Project One, which is a large ethane cracker that will be fed with scale gas from the USA in the first instance, but eventually we'll also have to switch towards more sustainable fuels, let's say, and they are looking at hydrogen as well, so might be a future user. ArcelorMittal in Ghent, as I mentioned, might be a future user. So there's the industrial offtake, and on the right side you see, of course, we're a port. We have a bunkering position today, so we're fifth largest bunkering hub in the world. 7.5 million tons of oil equivalent being consumed in our port today. Heavy fuel oils, fossil fuels, of course, but also there, regulation and our ambition is leading us towards more sustainable fuels. We see with IMO, that was also mentioned by Nishaanth in the beginning, that this will be an important offtake sector as well here in Belgium. So I think in the future we can dive into these two sectors in Belgium and maybe in the neighboring countries in a future webinar to spit out and to detail more where this offtake is coming from and how much it will actually be. So this is Belgium offtake. The name of the webinar was Port of Antwerp-Bruges Hydrogen Import Strategy and Hinterland Connectivity. So we're coming to the Hinterland connectivity part now, in the second part of this webinar. So I don't think I tell you anything new if I tell you that there is a huge consumption potential in Germany. So we have done a study together with Fraunhofer to map where this potential consumption in the future is actually located. Also there is no rocket science. It's North Rhine-Westphalia, of course, who is one of the target regions, heavily industrialized but landlocked, so they don't have their own port that can supply them. So they're looking very much at Port of Antwerp-Bruges, Port of Rotterdam as supply routes for their sustainable molecules. So we have identified these regions. We have ranked them in terms of importance, you see on the right. Plus, we also added a couple of first movers, in our opinion, due to European legislation or due to subsidies. For example, German steel companies have gotten a lot of subsidies, so we expect them to be the first one actually moving ahead with signing deals in the near future, hopefully. Yeah, this is just an overview. We are targeting all these companies in all these regions in Germany to have a bit of an overview of what is actually the amount they intend to consume, what is their timeline, what is the barriers they still experience, how can we help them. Some exercise that is ongoing this year from Port of Antwerp-Bruges sites. We talked about the pipeline and the connection towards Germany, which is, of course, crucial, will be very important, and hopefully we will be able to make the connection by 2030, as indicated before. That, however, does not mean that up until 2030 or up until the moment the pipeline is actually built, that we cannot do anything at this point in time. So we are connected to the German hinterland as well through rail connections and through barging connections already today. So you see two indicative numbers already on the slides. For example, 300,000 tons of methanol is transported to Germany already. In 2022, we transported more or less 100,000 tons of ammonia already towards Germany. That, of course, was gray ammonia and gray methanol, but it indicates that the capacity is there. And so the vessels are there, the wagons are there. So it's already possible today to make the switch towards sustainable molecules through these transport modes. And so we have done a study with Rebel, which you see on the bottom right, to actually investigate a bit how well is Port of Antwerp-Bruges or not well. connected to Germany in terms of rail and barge connectivity, and where are the bottlenecks, what should be done to make this large-scale ammonia import possible. So, and in the next couple of slides, I will present you the main conclusions from this study. So you see here in one slide or one overview what the study has done. So basically it has benchmarked 4 import locations, import hubs in Antwerp, Rotterdam, Wilhelmshaven and Brunsbüttel for the import of ammonia and methanol, but let's take ammonia as an example in this case, to 4 destinations in Germany, Duisburg, Leverkusen, Ludwigshafen. Geleen is not Germany, but the Netherlands. In terms of 3 transport modes, so barges, rails, and truck, also via roads. So you see that again explained here on the slide. So it's benchmarking ammonia and methanol supply from 4 import hubs towards industrial destinations in terms of connectivity, rail, barge, truck. What are the parameters that are investigated in this study? Is the cost, of course. What is the cost of taking the quantity of ammonia from Antwerp to destination X? Let's also take Duisburg as an example, as the main location maybe. This is, of course, influenced by the distance, how far you have to travel, but also, for example, what are the waiting times at locks, etc. So that is one parameter. The second one is capacity. How many wagons do we need? How many vessels do we need? Is there congestion on the railroads? Is there congestion at the locks? That's also investigated. Are there any barriers there? And then the third one is regulation. Are there any gaps from a safety point of view that are defined by governments? Because of course we're transporting dangerous goods with ammonia, methanol in a lesser extent, mostly ammonia. So those are the 3 things we have investigated. What you see here is the cost comparison between the 3 transport modes. Let's start with truck to already leave it out. You see, because it's smaller scale, it's of course far more expensive of transporting ammonia through trucks. So for the rest of the slides and the rest of the study or the comparison, we will leave out trucks. Also maybe from a safety aspect, I wouldn't recommend transporting ammonia through truck via busy roads in Antwerp and beyond. So it doesn't seem like a good idea. But if we compare barge versus rail, you see that more or less, in large extent, the 2 are competitive with each other. The types of barges you see is basically going from smaller to bigger ones. So the mostly used type is the middle one today, but there is still potential in the market to shift to the larger, the third one, which will be done probably in the future, making barge a bit cheaper in the future. And then for the trains, it depends on also the size of the trains or the size of the wagons, how many tons you can carry, and also do you find a return cargo. You bring ammonia from Antwerp to Duisburg, for example, but can you bring something useful back from Duisburg to Antwerp? This would also influence, of course, the cost of your transport. But main conclusion here is truck not competitive, and then barge and rail more or less at par with each other, could compete with each other depending on location, depending on size of the off-taker, etc. Okay, next. Yes. Then second part of the cost is, of course, the distance towards from the import hub towards the destination. Let's take Duisburg here. We see that Brunsbüttel is just basically twice as far or more than twice as far than, for example, Antwerp and Rotterdam. So it's just not competitive to import through that hub. To go to Duisburg, just to be sure, I'm not talking about the north of Germany, then the things would shift, of course, entirely. For Wilhelmshaven, there is no barging connection, so that's not a possibility. And for rail connection, it's also quite a bit further than Rotterdam and Antwerp. For Rotterdam and Antwerp, you see that they are closer to each other. Rotterdam is a bit closer, which is just also geography. If you would again open your Google Maps, you would already see that. So in this regard, Rotterdam is a bit closer and probably just a fraction cheaper than Antwerp for rail and barges towards Duisburg. We're taking Duisburg as an example. If you would take Leverkusen, Ludwigshafen, or Geleen, this would be the opposite would be true, but the differences are quite marginal, quite small. This won't be the main influence, I think, in the whole value chain. Then looking at are there any capacity constraints with two aspects. One is infrastructure and the other is the material. So for infrastructure, we're looking at rails and locks. I already mentioned that there is still possibility to switch to larger vessels in terms of inland barging, which would actually counter the extra traffic that will come on the River Rhine. So that will not be a problem. The same conclusion goes for Antwerp and Rotterdam. It's the same conclusion. What we have to think of, or what you have to take into account, is of course that due to climate change, the water levels on the Rhine tend to be during summer lower and lower and leading to problems from time to time. I know that, for example, 2018 was really a problematic year with very low water levels. So this is something that needs to get attention and that we need to work on. In terms of wagons for rail, on the track going through Belgium, there is a current occupation of 90 trains per day, while the capacity is 160. So meaning there is a lot of additional capacity, should not be a problem. For Rotterdam, the same is true. It's a bit less the additional capacity, but also there the railroad from a Belgian side or from a Dutch side should not be a problem. Then, of course, crossing the border into Germany might lead to different conclusions because the railroads in Germany are quite congested, but also there the German government is taking actions and actually tackling this. In terms of material, so the vessels and the wagons itself, there are currently 10 barges who transport ammonia already today, apparently in the market, while 30 in total would be needed to achieve the goals that we mentioned earlier, the 2030 goals. So that's an additional 20 vessels with a 2-year building time. So if we would make the order today, we would have it in 2 years. So also that does not need to be the hurdle, the hurdle in this supply chain. Of course, somebody has to order them, and that's of course true. And then for wagons, it's only 350 wagons extra would be needed on a fleet of 90,000, for example, at DB Cargo, which is a drop on a hot plate. So it's really not the issue. So conclusion here also in terms of capacity, some attention points, but this will not be the major problem. Then coming to safety, which is a different story. So there is European legislation called the ADN regulation that handles or deals with the transport of dangerous goods through barge and rail. And of course, ammonia is such a dangerous good. And there is a difference between the Netherlands and Belgium, where Belgium just follows the ADN regulation, so does no gold plating. In the Netherlands, there is actually a law called WaterstofNet, who limits the transport of ammonia over rail and barge over the Dutch territory. So you see here for barging, it's 150 kilotons. And I showed you earlier, there is already quite some traffic today over the Rhine River. So it's not that we have an additional 150 kilotons. I think around 100 or even more is already taken up on this river. So this is not something that we are actually happy with, because if you would take again a look at your Google Maps and you would have to sail from Antwerp to Duisburg or Ludwigshafen or wherever, we actually have to go first up towards the Dutch territory and then go over the River Rhine. So this is also something that impacts the port of Antwerp-Bruges. So this is not something that we are cheering for. But for rail, it's a bit different. This is not the nicest picture, I know, but I couldn't find any other ones. There is one rail track that you see circled on the bottom called the Monson route, which goes completely over Belgian territory, which still has additional capacity, as I mentioned earlier. And so if we would go entirely over Belgian territory, then this additional regulation from the Netherlands would not apply, and so would not impact us. So this is for us maybe the most realistic or competitive route, because additional capacity available, no regulation hampering, and cost competitive vis-a-vis the different destinations. So this is a bit the study concluded in a couple of slides. I have been talking a lot, so I will stop now. And if there is any questions from the audience, I'm happy to answer them. Taking a look at the chat as well. Will the presentation be shared? Yes, of course. I will share it in PDF. I see a hand raised, so please go ahead. I cannot hear you. I don't know if you're speaking
Stefan,
already. Yes.
I'll just take it up. There's a question in the chat box. When will the port import terminal be ready?
What project was it referring to, or just in general?
Soumya, do you want to unmute? Yeah, in general.
In general, yeah. So the projects that I showed you all had more or less the same timeline of 2030, which is not a surprise, or is actually quite logical, because European legislation that you probably know, Renewable Energy Directive, is actually defining a couple of targets for hydrogen consumption, both in industry as in transport. And the target is defined in 2030. So that's why these projects are, of course, all aiming at this timeline. Now, if you know that building such a terminal takes around 30, 32, 35 months to build a terminal, then you can do the math and calculate back that actually in the next, let's say, year, we need to start building these terminals now. It's not to put additional pressure on the terminals. What they're waiting for is, of course, commitments, off-take commitments in written contracts before they can actually take FID. So this is the same story that you probably hear in every conference that you attend nowadays. We need off-take, off-take, off-take. And so that's the main thing that we need to work on together now. But to answer your question, for now, aiming at 2030, because otherwise we will miss the targets that were set by Europe.
Thanks, Stefan. Stefan, another question in the chat box for you. The Netherlands has its own major ports and infrastructure development ongoing for green hydrogen. Could you elaborate on the rationale for the Netherlands importing hydrogen from Belgium, and what strategic advantages this cross-border offtake provides for both countries?
If you would have a look again at the picture that I showed you of the development of the hydrogen backbone, I highlighted the connection towards Germany, of course, because it's a bit of the holy grail, because it would unlock a lot of demand. But also, if you would look again, a connection with the Netherlands is also planned. So actually, from our port, from where I'm located now to the Dutch border, is not that far. It's 30 kilometers, and maybe the end of our port is really bordering the Dutch border. So we're working also on making that connection, so hydrogen can flow in both ways. It can flow from the Netherlands towards Germany. It could flow from Germany, from the Netherlands towards Belgium. It could flow from Belgium towards the Netherlands. I think this optionality will probably be an advantage in the future to see what direction it could go. I hope that answers the question partially.
If I may compliment, it's strategic redundancy in the whole connection in this area. Yeah, if we would not have any opportunity to cross-border transport hydrogen for whatever reason, it could be a deficit in the Netherlands, could be a deficit in our side, it could be a supply necessity towards Germany.
Yeah.
So there is an opportunity for linking everything together, and by the end, everybody will be happy if everything is connected. Strategically, it's not always the easiest point, but ultimately, operationally, everybody will be happy.
To add to that, of course, Rotterdam and Antwerp are often mentioned in a context of competitors and etc. We work together as well. So we don't. It's not that we're fighting neighbors all the time. The contrary is true. If the whole hydrogen economy develops one day, which I still believe that it will, it might be a bit later than we would have thought a couple of years ago. I think both import routes will be crucial. Also in the geopolitical context that we are in today, I think Europe has learned its lesson. I hope Europe has learned its lesson. I hope Germany has learned its lesson of not depending on one supply route anymore for its energy, but putting its eggs in different baskets and actually spreading out the risk.
That's true.
Thank you. Is there anyone else who wants to ask anything? Please feel free to unmute and go ahead. Yeah. Soumya is writing, what about your bunkering plans?
Good question. So that's actually a different colleague of mine who is specialized in that, so can definitely put you into contact with him to give you already a partial answer. Is that I mentioned we are a bunkering hub today. We wanna remain a bunkering hub in the future, and in doing this, we will be obliged to shift from the heavy fuels that we supply today or that we offer to the market today to also be able to offer more sustainable fuels in the future. So, in that regard, we have taken a couple of steps already. So also this you can find on our website. For example, what we have done is we have developed a bunkering map of our entire port, both in Antwerp and in Bruges. So if you would Google bunkering map Port of Antwerp-Bruges, you will find it immediately. And it's actually a tool you can play with that you can select your fuel, for example, ammonia, or for example, LNG or methanol. And then our port will be colored in green and red parts, let's say. Green indicating bunkering of this fuel in this area in the port is possible regarding safety. Red is not possible. Red could be because, for example, there is a public road nearby, there are offices nearby, etc. So this is an exercise we have done. The good news is that all the big terminals in our port today are turning green, which is, of course, a very good news. So we could bunker ammonia there without problem. What we are also doing is working together with the bunkering operators to provide them with licenses to bunker these alternative fuels, to give them training regarding bunkering of these more dangerous alternative fuels. And we're working also on what we call SIMOPS, simultaneous operations. So making sure that the bunkering of the fuel and the loading and unloading of the vessel, of the cargo, can be done simultaneously, because of course time is money in our port, and we cannot do a bunkering operation of 24 hours and not loading, unloading the vessel. This would increase the cost a lot. And in this regard, we have already done green methanol bunkering in our ports a couple of times with the Anna Maersk. Also that you can find online. One of the largest seagoing vessels of Maersk. We've done biomethanol bunkering, and we're working by the end of this year, beginning next year, to also have a first ammonia bunkering in our ports. If you would like more information, I can definitely put you into contact with my colleague. Just give me an email. My email address was in the slide, so happy to put you into contact.
Thanks, Stefan. Next question. What is the ratio of bunkering planned at POAB, methanol, LNG, and ammonia?
Difficult to tell, I think. Again, we'll put you into contact with that same colleague. He is very much at this point in time really on top of analyzing the IMO regulation. Also the Renewable Energy Directive that I mentioned earlier is being translated into national law in Belgium. It has a sub-target for the maritime transport sector, so we are happy with that. It's an extra stimulus. So he is really crunching the numbers, what it could mean for our port, what it means for the different molecules or the different fuels. But I have to be honest, I could not answer your question out of the top of my head like that. But hit me up with an email, and I will give you with an answer. I'll provide you with an answer.
And is POAB planning to invest in any of the Indian port?
Well, for the moment, We don't have any stakes yet. So I mentioned Brazil, Oman, Namibia as concrete cases. We are definitely, of course, open and interested to see what is possible in India as well. This is also part of this, one of the reasons that we signed this MOU, to understand a bit more the port landscape in India. We are probably coming with a delegation in India, towards India for the India Energy Week end of January, and so we hope to speak a lot of interesting players, ports, maybe the ministry that is in charge of the ports, and to see how we can help each other. So if I don't know who asked the question or from what company, but definitely interested to enter into discussions with you in that regard.
Okay, thank you, Stefan. And with that, I think we'll conclude this session. Thank you, Bert, and thanks, Stefan, again, and the whole team of Port of Antwerp-Bruges and DHC for joining us. It's been great to hear from both of you, and we look forward to collaborating more in the future. Just for our participants, the presentation will be available in a couple of days. Stefan will send it to me, and I'll make sure to forward it to all of you. And on the sidelines, GH2 India is planning a visit to the port of Antwerp-Bruges on the 2nd of October. In case you guys are interested, please write to me directly over mail. And thank you once again for joining. We look forward to hosting you in many more webinars.
Thank you, Kemia. Thank you. Bye.
Thank you.
Thank you,
Bye.
Nish. Thank you, everybody.